Alright, so we're going to try something different. I'm going to be recording my notes today. So you can pause and you can play whenever you need to slow me down, and the notes are still going to be online. Alright, so today you are going to do the Pythagorean Theorem. And on Friday I spent a lot of time proving it. I went through like 7 different proofs. So today we're actually going to use it to find sides, find the legs, and the hypotenuse. So here we go. You should write Pythagorean Theorem, and I believe this is going, for me, it's page 10. All right, so here we are. I'll write it right here. Okay, so here is the wording of the actual theorem. In English, it's the sum of the squares of the legs are equal to the square of the hypotenuse. So let's write that out first. If a triangle is right, then the sum of the squares of the legs are equal to the square, the hypotenuse squared. Okay, so if we have a picture of a Pythagorean triangle, a right triangle, and we have A and B, these two right here are called the legs. The reason I know that is they are sitting around the right triangle, and then this is going to be C, the hypotenuse. So it's hypotenuse. And even if we didn't have a picture, we should be able to know which one is the hypotenuse because it's always the longer side. So, for example, if I start rotating things around, this is a leg, this is a leg, and this is the hypotenuse. I would still do a squared plus b squared equals c squared. Okay, so let's do some examples of these. Like, for example, if I give you a triangle that has 8 here and 10 here, I should be able to find out the other side. So I know that this is the leg and this is a leg. The hypotenuse is always across the way from the 90-degree angle. So that's going to be my C. So it says you sum a leg, square a leg, 8 squared is 64, plus you square the other leg. And I don't have that, so I'm going to put x there. I'll just do x squared equals the hypotenuse squared, which would be 10 squared is 100. And then we do some algebra here. I want to get x alone, so I subtract 64 on both sides. That's going to be x squared equals 36. Now to undo a square, I square root. And so what number squared would be 36? That is 6. So I know that that side is going to be 6. That's the other leg. My legs are 6, 8, and then 10. They might ask you follow-up questions like, what is the perimeter? Well, there's 10, 8, and 6 all along the outside, so that would be 24 units. And then the area would be using the area formula for triangles. So 1/2 base times height, which would be 1/2. And in this case, I'll call 8 the base, and the height will be 6. And I don't include 10 because 10 is the slant height. So this would be 4 times 6, because I could do those first. Half of 8 is 4. 4 times 6 is 24 units squared. And teachers would probably avoid this problem because the perimeter turns out to be the same as area in this case, but it's not always going to be that way. That is a fluke. So we're going to do another right triangle here. Here's another example. All right, and so we have this triangle. It's a right triangle with 10 and 7. So we need to find the last side, and then we'll go over perimeter and area. Just keep in mind, in the book, they're probably not going to ask for a perimeter and area every time, so just follow the instructions. So first, find the other side. My legs are going to be 7, and I don't know the other leg, so I put x there. And then I know I have to square both the legs, 7 squared and x squared, and sum them, and it should be equal to the hypotenuse squared, which is 10 squared. Now that would be 49 plus x squared equals 100. And guys, I'm telling you that you're going to be tempted to try to do this all on your calculator. Be careful. I would not do that. Write it out. When in doubt, write it out, because especially on baby calculators or scientific calculators without where you can't type everything in a line, often you can get things mixed up because your calculator doesn't do PEMDAS. So what I'm saying is write out every step just like I'm doing here. Alright, so I'm going to subtract 49 because I want to get x alone. So x squared equals 51. And I don't know what the square root of 51 is. So I can write the square root of 51. And then I need to pull out a calculator. Okay, here we go. The square root of 51. 51 square rooted is 7.14, let's say. 7.14 units. Okay, so if they ask for the perimeter, we would just add up the legs and the hypotenuse. That would be, well, 7 and 7.14 is 14.14. So it's 24.14 units for the perimeter. If we're doing area, we still use the 1/2 base times height, and that would be 1/2 times, be careful because remember the base and the altitude have to be at a right angle. So in this case, the base would probably be what x was, which was 7.14, and that means the altitude is kind of going down like this. So that would be 7 right there. Alright, let's get out our calculator, clear it. We would do 0.5, which is 1/2, times 7.14, times 7, and I'm getting an area of 24.99 units squared. So I've been picking weird triangles because it always seems to turn out that the perimeter is close or exactly to the area. But when you do this, you're going to see that that's very different. Alright, that's not all you could do with the Pythagorean theorem. There's something called the converse of the Pythagorean theorem, and if you remember, converse is when you take an if-then statement and flip it around. So before you had if, then. So if a triangle is right, then you know the sum of the squares of the legs are equal to the hypotenuse squared, okay? If it's right, you can do a squared plus b squared equals c squared. Now, we're going to write it this way. If a squared plus b squared equals c squared, then it's right. So what they would often do is they would give you a triangle. They'd give you the triangle sides. So the sides that we're going to work with are 7, 25, and 24. You would have to check to see if it's a right triangle. And so to do that, you would fit it into the Pythagorean theorem and just see if it works. Remember that your hypotenuse always has to be the longest side. So I look at 25 and I say that has to be my c. So on one side I'll have 25 squared. On the other side I'll have 7 squared and 24 squared. And remember, you would add those up. So this would be 49 plus 24 squared. Is that 596? 576. All right. And then 25 squared, I've been around long enough. I know that's 625. That happens a lot in algebra. All right, and then we add 49. So I'm just going to write it below. Carry the 1. This is 8 times 4 is, or 8 plus 4 is, okay. Now this checks out, meaning that the triangle sides they gave us could make a right triangle. If they don't equal each other, then you know it's either it's going to be not a right triangle, obviously, but we'll go over tomorrow how to tell if it's acute or obtuse. Okay, so I wanted to show you two more examples. So, for example, this is the way they would hide a right triangle. Okay, a rhombus has diagonals, and I want to do diagonals 6 and 8. The question is, what is the perimeter? All right. So first, we have to figure out all of the sides of the rhombus. But in this rhombus, all they told us was that this width right here is 6, and the total length is 8. But if we focus on just one of these triangles, remember that in a rhombus, the diagonals cross at a 90-degree angle. If you put that 90 degrees there, this means that this length is half of the total width, which means this is actually 3. And so the other side here is going to be 8, but that's going to be 4 when you cut it in half. And now we need to figure out that length right there, the hypotenuse. And you guys see that with a rhombus, we know that all the sides are the same. So whatever we find for this hypotenuse, you times it by 4 to find the total perimeter all the way around. So my legs are 3 and 4. So I do 3 squared plus 4 squared. And then hypotenuse is x squared. This will be 9 plus 16 equals x squared. So this is 25 equals x squared. So x is 5. That's not the total perimeter though, so we need to make sure to times by 4 to get our full answer. Perimeter equals 20 units, whatever those units are. And I want to show you just one more reminder. We did this a little bit with inscribed circles. So let's say we have a circle and we have a diameter in the center here. A lot of times they like making triangles like this. Now what I'm highlighting here is an inscribed angle. Okay? The reason is the vertex is on the edge of the circle. Okay, but another important thing is you remember that the inscribed angle should be half of the arc it intercepts. Remember this arc right here. If that's half of a circle, this has to be 180 degrees. If that's the case, then half of that would be 90 degrees. So they wouldn't tell you all this, but when you see that kind of setup, you should be thinking that that inscribed angle has to be 90 degrees. What they would do then is that they would say, oh, this side is 5, this whole length right here is 13, so they would want to know x. Really, it's a Pythagorean triangle problem hidden in a circle. So just be aware of that. All right, so your assignment is posted on the calendar. I want you to go back to the calendar and just take a look at that. And then you'll need a clean piece of paper, and you'll have to get out your electronic textbook. Or share with your partner and go get a real one.